I'm calling this one Starting System Stories because it covered a little bit of basic stuff on starters and the wiring and stuff, but I've got some stories to tell too. And starters are something that probably one of the most common things that we have to deal with in the service bay. Figured out what's going on with starters. You might remember the test I did last week had some stuff about starters in it, but this is a new bunch of stuff I'm talking about. To begin with, what you got here is you got this solenoid. It's got an iron core. Everybody's familiar with this. There's a little wire that comes through the neutral safety switch from the ignition switch usually, and it energizes this solenoid. And when it pulls this back, it goes into this gear goes into the flywheel. It meshes with the flywheel before the starter starts to spin. That's really important. And it slaps this copper washer against these two studs. This comes in from the battery. That feeds a starter motor. And then there you go. That's how that basically works. It's a real quickie here. All right. This field coil on the other ones was wired in series with the brushes, so that when you put 12 volts in there, you were creating a magnetic field here, and these brushes were basically creating a magnetic field that was the poles were the same, so that the motor constantly ran from itself. So there's a lot of stuff going on here. And then you've got your overrunning clutch right in here. Permanent magnet starters, I'll talk about the overrunning clutch in a minute, but permanent magnet starters have these magnets around here, and they do the same job the old field coil used to do. But most of the time, these permanent magnet starters look like this, and they'll have a small starter motor that spins really fast, and it will actually engage through a planetary gear set, which slows it down, but it has more power. So you got a smaller motor, the planetary gear set steps up the power. It's faster, it spins that planetary gear set, which is basically what drives these, and I can give you a breakdown on that, but you get the point. They want a smaller motor with this permanent magnet motor. That's another reason why you got to be careful when you're whacking on these with a hammer. You can break those magnets, so be particular about that. All right, so here's your starter drive. That's what a starter drive looks like whenever it winds out. Whenever it starts to spin it, and then it goes, whee, you notice how the shaft is still spinning? When that thing goes bad, it does that. These little rollers here basically roll on a ramp, and whenever the engine starts, if that's still engaged, it'll basically allow it to spin freely. It's like a one-way clutch, Sometimes you might want to call it a sprag, like in an automatic transmission, but sprags are little bow tie shaped things. This is basically a roller ramp, roller riding on a ramp that's spring-loaded, and that's how that operates. Back in the day, in the 70s, we used to rebuild starters all the time. We'd put bushings and brushes and starter drives in them, and we just tear the starter down right there on the bench and rebuild it and put it back in. That was a fairly common thing to do. Nowadays, it gets getting a little harder to find starter parts, unless you're somebody that's a specialty starter overhaul shop. We had one of these here in this town, but it's finally closed up. Voltage is really important. If you got all this stuff slowing your voltage down and dropping voltage, this bad ground is a thing, that's really nasty. So if you're going from the hot side of the starter to here, when you're spinning it over, you're not supposed to have, and I just love that thing. Ooh, that pops up within 5 minutes. Anyway, this thing right here, you're not supposed to have more than a half a volt there and a tenth of a volt there. That's on the negative side. And you've got to have the voltage. You got to have the starter spinning when you check this. And you can actually check any circuit that you want to check voltage drop on that way. Like for example, if you've got a headlight issue, there's a dim headlight on one side, you can go from the hot side of the battery to the place where the voltage is going into the headlight with the headlights on and see how much voltage you're dropping between the battery and the headlight. And you can also check from the ground side to the ground wire on the headlight. Now whenever you're checking, if it's a 2-filament light, you got to make sure you go into the filament that's lit up, the wire that's feeding that one. But I have seen this thing right here cause trouble. See, that right there is a factory connection. And it's dependent on all kinds of, there's paint in between there and all that. And I heard a long time ago about I've mentioned it on here before, but there was a Mazda RX-7 back in the 80s that kept destroying axle bearings because of a bad ground on the engine block. And it would basically, when they go to start the car, it couldn't get a ground through the engine block boss like it was supposed to, and so the ground's going to find somewhere to go. So it ran down there, it ran out through the axle, arced on the bearings, came back up the park brake cables into the body of the car, and then the car would start. But it kept arcing on those bearings and burning them up. They replaced differentials and bearings and everything else trying to fix it, but it kept destroying them, and they finally just gave up. And the guy at the training center where the car was given to found it. But pay a lot of attention to this kind of stuff. I despise this kind of thing. I always try to do everything I can to fix that whenever I'm working on one. Even a lot of times I'll give them one of these battery cleaning, just so we won't have a problem later. You know, wiring, switch controlled wiring is, this is, back in the day, some of you, or if you're old enough, or if you're a buff on older vehicles, you might remember some of the old Chevys used to have starter pedals on the floor. And the starter pedal, when you mashed the starter pedal, had a little lever down there that would push a big fat button on the starter, and that would engage the starter. Of course, the starter pedal was right next to the gas pedal, so you could work your throttle while you're doing it and have your choke pulled and all that kind of stuff. And for a long time, the Napa store here in town still sold those switches that went on the starter, because sometimes those switches would go bad and you had to replace a switch on there, for that kind of thing. And that was before the time of clutch switches. Well, now you got a clutch switch, and you've got a neutral safety switch, if you want to call it that, the parental switch on the transmission. You've also got relays that will drop the starter out based on passive anti-theft and various other different things. On the first 89 Super Coupes that came out, and Thunderbirds and Cougars, you had to put your foot on the brake before the starter would work. I hadn't hardly seen that on very many cars, but I remember that was the way those were wired up. Anyway, this right here is your starter is pictured right here. The starter relay on this one here, see, if you turn this thing to start, it's going to go through here, and you notice you got an alternate current path from 92 to 93 on this particular one that I did. If it's a 92 model, it's energized in the starter relay, which pulls that over and drives the starter. On some of it would come straight through the switch. That's why I put that one up there, because it kind of covers all of the older ones, and usually have some good strong redundant grounds down here. All right, your PCM controlled, like on a Silverado, you might know on these GMs, you just touch the key and then let go of it, and it spins until it starts up automatically. That's because when you turn your ignition switch, you're telling the BCM to go over the network to request the PCM to operate the starter relay and to do your starter motor there. I could go into lots and lots and lots of wiring on these things, but that's basically how that works. This is what it looks like on a 2008 Impala. Now the difference between this one and that one, this one here, you can control the start. You can actually, replace the starter relay separately and most all your other relays. But a lot of these GM cars nowadays, they like to be set up your main PCB relay on this one here. It basically goes to the engine controller and turns it on, and then it does a very similar job to the Silverado. The starter relay can be replaced. When you see numbers by those terminals, that's a replaceable relay. When you don't see numbers by the terminals, it's built into the box. That's the way this one is. That's the way it was on that Impala that we worked on. All right, so what you can do is go to your scan tool, and it's basically reading this right here when you're looking at ignition 1 signal. If that's not high enough, because there's not enough power coming through this relay, and we ran into one like this, we had to go in there and find the wire that was leaving, behind the fuse panel, and check it for voltage. We had good voltage coming in on that wire, but we had lousy voltage, almost none coming out. And that turned out to be the problem. We had to replace the fuse panel on that particular one because the car wouldn't start. All right, now this one here is really crazy, and we worked on one of these that kind of beat us up, and I'm going to tell you how all this worked out. But on this one here, your engine control relay is built into this box here. If you buy this box, it's actually a Mercedes part, but if you buy it from a Chrysler dealer, it's $400 or $500. There's places online you can get exactly the same box for 120 bucks, so you don't have to pay $400 or $500 for it. But it's one of those deals where they're packing the relays all into one module where you got to buy the whole darn thing. You can't just swap out one relay unless you want to get, creative and go in there and solder a new one on the board. And I've done that kind of thing too, but not lately. Anyway, this engine control relay has got to turn on, see the PCM turn on. Whenever the ignition switch turns on the engine controller, PCM, it turns on this relay. That turns that on. This turns that on. So your PCM is going to have two things. It's going to have an ignition switch input and a PCM turn on input. It's got two different wires it's got to fire up at the same time. And there's your starter enable, goes to the pulse module. A little pulse module's on one side of the engine compartment. It's over on the left side. And this thing here is over on the right side. So on two opposite sides of the engine compartment, on this '05 Crossfire, you got modules that are really important. You try to look this one up and buy it online, you're going to have a really hard time finding it. If you try to look up a pulse module for an '05 Crossfire, they're always going to try to throw you one of these. That's a different box in a different spot with a different job. Alright, so your starter solenoid is finally operated by the pulse module based on the orders it gets from the PCM. But in order for the PCM to do this job, the PCM's got to be turned on. So we had a Chrysler Crossfire. This lady took this Chrysler Crossfire to the Chrysler dealer somewhere, wherever it was, and they worked on the thing, you know, because he said sometimes she'd go out there and she would try to start it and it just wouldn't do anything. It just turned it on and it would just do nothing. Okay, and so I said, well, she said, what I did was I was trying to, get the Chrysler place to fix it, and they changed the engine controller out and hit her for $2,500 worth of other stuff and all. And a couple of days later, she turned the key and it still wouldn't start. And she was exasperated with them. She did what a lot of people do. Instead of going back and making them make good on what they did, she brought it over there to us because she worked at the college anyway. And so I said, well, what we got to do is we got to take this intermittent problem she's having and turn it into, find a way to record it. Now, I had a slick little tool here. Now, this is actually, I basically wanted you to see what was supposed to happen. See that? Well, all of the red wires are hot whenever you turn it to the start position. Now, that switch is not quite drawn right, but you get the point. These two are basically, it's gang switch, but they're hooked together in one spot, not right there, though. But anyway, what we were getting was this. We were basically getting this right here, but we weren't getting that. And because we didn't get that, we didn't get this, and we didn't get that. So that's what our problem was. So how did we find it? This is how we found it. We got this Wacom Industries flat recorder WAE 45364. Now this thing actually only has 4 channels it can measure, but it gives you good resolution. There's a little software package you put on your engine controller, on your shop PC or your laptop or whatever to pull up the recording it made. And it's got a little button. And so I wired this thing up. I wired it up to the PCM feed, the battery, the spark, the injector pulse width, and all that. So that's what we did. And I put that thing, I taped that to the wheel. I says, the next time this thing doesn't start, because most of the time it would start, and it's just sometimes it wouldn't. Next time it fails to start, I made a recording. This was the recording I made when it was working like it was supposed to. And I said, make a recording of it the next time it doesn't start. And then, when you can get it to start and get it in here, we'll pull that recording and we'll find out what's going on. All right, and so this is the recording that she made. The battery had a good strong 12 volts. There was no spark, there was no pulse width, there was no PCM feed. And I had basically found this is where I measured it at, the PCM feed. I measured right here on pin number 6 coming out of that thing. Okay, all right, so anyway, it turned out that this is what the problem was. So we put one of those on there and she never had that problem again. Well, that is what I was able to do with that particular seed, not being able to catch it. A lot of the times if you're there with your test light or your meter or whatever, and you're starting it over and over and over and over again, this thing had to sit overnight and have a hot soak, be in a garage and all that hogwash before the problem would happen. And, you'll spend a lot of time doing that. If you can figure out a way to get the customer to make a recording or do like a little box I built with the fuses and the lights in it, that will pinpoint what your problem is. And in this case, it did. Now, there could have been a wiring problem or whatever, granted, but it turned out that that's what the problem was. That's the Mercedes part number of it right there. That's the actual one that we pulled off the car. All right, so what's this starter right here? This starter right here was on a 97 Mazda. The first thing you're going to see is a starter that is not quite working right. It's kind of slow and sluggish. Watch how slow and sluggish it is. This is on my YouTube channel, by the way. You can hear it. It's turning, but it ain't really turning all that great. All right, and now that's just terrible. Now watch the good starter. Watch what happens with the good starter. See how much faster it turns? Now you can look that up on the YouTube channel if you want to. All right, now I hate it when it does that. Hold on a minute. It wants to show me all those other videos. All right. Now, the 97 Mazda's problem, to begin with, they put a lot of superfluous stuff on the wiring schematic, you know, that makes it a little bit aggravating to track down. And what I like to do, you know, when I'm doing a little teaching like this, is I like to clear a lot of this trash out that doesn't need to be there, so that we can basically see what we're talking about. But you got a gang switch up here, and that gang switch is basically supposed to go in here. Let me clear the trash out. Okay, let's clear the trash out. So this is a normally closed relay. When this module energizes that relay, it's kind of like the old Ford air conditioner relays. Remember that? The old wide open throttle cutout relays. The normally closed terminals carry the starter current. Right? Now, I never have liked these normally closed terminals, even on the wide open throttle cutout relays, because it doesn't have the nice tight bite that it does whenever it energizes the relay and pulls it with that magnet. But anyway, nonetheless, that's where that goes, unless this central processing unit, for anti-theft purposes or whatever, decides to energize that. Okay, in this particular case, they're supposed to come through here, goes through the neutral safety switch if it's in park or neutral, goes to the starter, and there you go. All right, now here's the problem. This person that owned this car had put a starter on it. An aggravating starter to change, you know, but I mean, he had done it himself. And it didn't last very long. It started okay to begin with, and then it got to where it wouldn't start very good, and the starter was kind of burned up. So he said, well, it was a used starter that he put on there, so we'll go ahead and put a new starter on it. And so we got from the parts store, we got a new starter from Dorman or whatever, whoever made the starter, popped it on there. It fired up and ran great, but the more you started it, the worse the starter worked, until finally the starter wouldn't do anything. And so what I found out was, if I took, even when the starter was spinning slow and didn't want to do right, if I jumpered the starter right down there at the solenoid switch instead of spinning it with the key, it would spin really fast. And so what the deal was, and this is an unusual problem right here. See this one here, the way that's supposed to work. See, I got that one all painted red again. I mean, I even actually changed the switches. See how the switches are closed now? That's kind of tricky to do whenever you're trying to make a, you know, do something. But anyway, we had a 3-volt voltage drop between the hot side of the battery and the trigger wire is coming through here. And it turned out the problem was that relay right there. That starter interrupt relay had weak contacts right there because it was just laying with spring pressure against there instead of pulling tight. And that's what kept burning up the starter. We got another new starter, we replaced that, and he never had any more trouble. Another option to fix that would be to do a push button thing, you know, to just run a push button directly through there, and, you know, bypass all of the other hogwash, including this. Anyway, but anywhere on that circuit, if you get right down to it, anywhere on that circuit between the ignition switch and the and here could have been your voltage drop. This right here is the easiest thing to access and the easiest thing to deal with. It turned out that was what it was after all, whenever there was current trying to flow through there. Okay, now you might notice this is a the little, well, I'm not going to talk any more about that because I need to move on. All right, my 2007 Taurus. One time I was down at the grocery store on my Taurus, and I always look after my stuff real good. I change the oil when I'm supposed to. I change the coolant when I'm supposed to. I watch the brake. I'm keeping track of this and making sure I maintain it. And I was really surprised one day, then at the grocery store, whenever it you know, it acted like the battery did. So I had this little bolt power, little brick-looking thing, you know, I hooked it up and it started up. Drove it back up here, checked the charging system while it was still running, everything was okay. Let me spit out 14 and a half. I switched it off, and when I went to restart it, it did it again, so I had a starter problem. So I went ahead and went down to the parts house and bought a starter, jacked it up, put it on jack stands in the driveway, and popped a starter on it right quick. Pretty easy job. You know, Taurus starter on a 3-liter is not a big deal if it's the little Vulcan engine. Anyway, I popped that thing in there and started it just fine every day, 2 or 3 times a day for a solid month. Well, over at the school one day when I was leaving to college, I went to start this thing, and it sounded like the starter began to spin before the gear ever entered the flywheel. That is a theoretical impossibility because this lever is supposed to throw that thing into the flywheel before it ever makes the connection between the battery to the starter motor. And that was the wackiest thing I'd ever seen. When I turned the key a couple of, it's making it a loud, ugly noise. You could tell it's just jittering off the flywheel teeth. And I said, I'm not going to keep doing this. So I got another ride home. It was late in the day. And the next day, because I was, I bought the starter from the same parts store, same franchise that here in my town in the college town. I actually took this starter off and sent it over there, and they sent me another starter and put it in there, and it never gave any more trouble. But that was a wacky situation, and I never really understood how this could start spinning before this made contact. Unless there was something in there that was, causing it to make contact early, or something came apart in here or something like that. But this right here is a story about the '71 Eldorado. Now, this was a vehicle that belonged to the president of the college. And notice on this old GM car, that Eldorado starter is not the kind of GM starter you're used to seeing. It's got ears instead of going up from the bottom. All right, so these flywheel teeth are nice and sharp right here. But whenever the thing first came to it, it had teeth knocked off just like that right there in about 5 or 6 different places on the flywheel. Now, what a lot of people don't realize is usually when you switch the vehicle off, the flywheel usually stops. I mean, the engine usually stops in one of two places, so that the most of the time the starter is hitting the flywheel in about the same spot, or one of two spots. Because there's always one place on the engine where it, likes to stop. That's just something I noticed a long time ago, back when I was working at a gas station in the '70s. But anyway, what I did on this one here, I noticed that starter was really, really, really powerful. And I took and egg-shaped the hole on that starter so I could actually adjust it so it would be closer. And we put another flywheel in there. And we wanted to make sure that everything was just like it's supposed to be as much as possible. And did you know, by the way, that thing's chipped teeth off that flywheel again? Now, whenever he bought the car, it had been chipping teeth off the flywheel, just knocking them slam off. I ain't talking about breaking them off this way. It was shearing them off that way when that starter drive shot out there. That's typically what that means. You notice these other teeth look normal. But if that thing is shooting out there with such an incredible amount of force, and this is kind of rare, you don't usually see it, if it's hitting those square teeth, you can see how it'll knock one off like that, because that's really hard and brittle stuff anyway. And so what I did to fix that one was I got another new flywheel, and I looked at the way that, you ever notice the gears on the starter drive are chamfered. And so I got my little high-speed cutter with the abrasive disc on it, and I laid that flywheel up on the bench, and I chamfered each and every tooth so that it was the opposite of the way the chamfer was on the starter drive. And that way there was no way that thing could hit straight on and knock another tooth off. That has been, trying to remember, 6 or 8 years ago, and he's never had another problem with that thing knocking teeth off that flywheel. Now, this thing right here, to be honest, you had a doggone 76 model 500 cubic inch engine that they had put in a 71 model car. And when you've got a little product variability in the way they bolt up and everything, like Johnny Cash's one piece at a time and all this kind of stuff, that thing wasn't quite lined up right. Of course we adjusted it and all that. Now, a lot of times you might not know it, I didn't put diagrams on this, but on the GM starters that bolt up the old-fashioned way, where the bolts go straight up, back in the day, in the 70s and early 80s, we used to have to shim those starters, not with just the shim going all the way across, but if you put a washer on the outboard bolt, it moves the starter closer in so that it'll mesh better. If it's meshing too close, you can put just one washer on the inboard bolt, and it will tilt the starter so that it's slightly farther away. It's supposed to be from the bottom of the starter gear teeth to the flywheel, supposed 40 thousandths of an inch, like a paper clip, thickness or something like that. But just take that for what it's worth. I'm not really going to go too crazy about that. Anyway, that's pretty much what we've got going now. I'm going to go ahead and take my dad out to lunch today, and so we're pretty much through with our presentation here, and I really appreciate you guys watching. Hope you enjoy it. Hope you get something out of it. And until next time, we'll see you.